Hello and welcome back to Miles Maths. This video is on transformations of graphs, and all we're going to do today is a summary of transformations of graphs. And this is just all the rules that we've been looking at in the other videos. And we're going to use a generic function, y equals f of x. So y equals something that happens to x. That's all we need to know. And we're just going to consider the 6 cases. So f of x could be anything. Could be sine x, cos x, x squared, x cubed, 1 over x. Doesn't matter. So here's the first case. The first case is y equals f of x plus a. And this is very similar to y equals x squared plus 2 that we looked at, because a can take any value. A is just a number. So y equals x squared plus 2, we know would translate the graph of y equals x squared by the vector 0, 2. So it would move it up the y-axis by 2 places. That's all it does. Or move it up in the y direction by 2 places. So this is a translation. We know it's in the y direction by a, or we can think about it being using the vector 0, 2 as a translation. If we consider the second case would be y equals f of x plus a, where the a is within the function. So this is similar to y equals x plus 2 all squared. Now we know this is a translation. If we remember back to previous examples, this would be in the x direction because the a is now inside the function. So this is going to be, whoops, nearly wrote y again. This is in the x direction by minus a. Or if you think about it another way, this is 2 places, or a places to the left. So, or you can think about this as being minus 2, 0. So what we remember is, if it's outside the function, it does what we expect and it's in the y direction. If it's inside the function, it does the opposite of what we expect and it's in the x direction. So if we continue with the second one of these, we consider y equals a f of x. So we have a multiplier. And we know that these represent a stretch. And if you remember the previous examples, things like y equals 2x squared is how we introduced this. So this is a stretch in the y direction. We know it's in the y direction because the a is outside of the function. It's by a scale factor of a. So it does what we expect. It's in the y direction and it's a scale factor of a. It's exactly what we expect because we're multiplying by it. However, if we look at y equals f of ax, where a is just some value, this we know is a stretch. It's inside the function, so it's in the x direction. However, this stretch is by scale factor 1 over a. So if again we remember the graph of y equals x squared, when we had y equals 2x all squared, what that did was it produced a graph which was half as wide. In other words, a fraction, 1 over a as wide. So we produced what some people call a compression, but what is technically a stretch by scale factor 1 over a. So if there's a 3 in here, the graph effectively becomes 1/3 as wide. If, however, a, of course, is a fraction, which it could be, a could be a half, the graph would be twice as wide. So it does the opposite of what we expect, and it does it in the x direction, and the a is inside the function. So the same thing applies. Outside the function, does what we expect in the y direction, the a is inside the function, the multiplier, whatever a is, it's just some number, remember. It does it in the x direction, and it does the opposite of what we'd expect. And then finally, we have the two reflections. Y equals minus f of x, which is a reflection. This is outside the function, so it's in the y direction. So I could say if it's in the y direction, it's a reflection in the x-axis, because it's in the y direction, up, down. And then, of course, we have y equals f of minus x, which is a reflection in the x direction. We know it's going to be in the x direction because the negative is inside the function. If it's inside the function, it's x direction. And therefore, this is effectively a reflection in the y-axis. And that summarises at GCSE everything you need to know about the transformations of graphs. Those are the 6 rules you need to know. And as I've said repeatedly throughout this video, if whatever you're doing is outside the function, plus a times a, with a negative outside the function minus f of x, that means that it's going to be in the y direction and it does what you expect. If it's inside the function, f of x plus a, where it's x plus a all inside the function, or ax, the multiplier, is inside the function, or the negative is inside the function, it's in the x direction, and it will do the opposite of what you expect. In other words, rather than going 2 places to the right, it will go 2 places to the left. Rather than being a stretch of scale factor 2, it will be a stretch of scale factor 1/2 in the x direction. That's all you need to know. Thank you for coming back to Miles Maths.